Assalamu alaikum. This is AS Chemistry and today we're doing mole calculations. We're going to go through all of the different types of mole formulas and calculation questions that you're going to come across in AS and even in A2. So let's begin. The first equation, which involves moles, is the ideal gas equation. PV is equals to nRT, and I have all of these different things labeled here so you know what's going on. The P in the equation stands for pressure, which should be in pascals. The V stands for volume, which should be in meter cube. N is obviously the number of moles. R is the gas constant, which has a fixed value of 8.31 joules per Kelvin per mole. And the T stands for temperature, which should be in kelvins. Now, when you're doing questions that involve using the ideal gas equation, you should be very careful with the units, because if your units, let's say the pressure is in kilopascals and the volume is in decimeter cube, you're gonna get a completely different answer. And so for you to get the right answer, you need to have your data in the right units. And so the conversions are important. And so I have some shortcuts for you here. So if you have volume given in centimeter cube, you're going to convert it into meter cube. So you're just going to multiply your given volume in cm cube by 10 raised to power minus 3. If your volume is given in decimeter cube, then you're going to convert it into meter cube, you're going to multiply it with 10 raised to power minus 3. If you're going to convert your pressure, which is given in kilopascals, into pascal, you need to multiply it with 1000 or 10 raised to power 3. And for going from temperature in Celsius to temperature in Kelvin, you just need to add your temperature. Whatever temperature you've been given in Celsius, just add that to 273, and that gives you your temperature in kelvins. Okay. Moving on to the first question. So at a temperature of 60 degrees Celsius and a pressure of 250 kilopascals, a gas occupied a volume of 1100 centimeter cube and had a mass of 1.60 grams. Find its relative molecular mass. So we want MR. Okay. So the first thing before we start any calculations is the problem with the units. So I have the temperature in Celsius, and I have the pressure in kilopascals, and I have the volume in centimeter cube. So this is not at all what I need. So I first need to convert. So for the volume, I'm just going to multiply. So this is 1100 centimeter cube. So I'm just going to multiply it with 10 raised to power negative 6. And that should give me my volume in meter cube. And that gives me 1.1 into 10 to the power minus 3 meter cubes. Okay. Then the temperature, that's easy, 60 plus 273, and that's going to give me 333 kelvins. And last is the pressure, the easiest of all. So pressure is in 250 kilopascals, so times that by 3, and that's gonna give you, I just wanna make sure that I put the correct number of zeros here. So that's this, yep, in pascals. Next, we solve the question using the equation. So we want the number of moles because we're going to use to find the relative molecular mass, which the MR, we're going to have to use this equation, right? And so for us to be able to use this equation, we first need this, because we already have the mass. So let's first find the moles using the ideal gas equation. So we're going to rearrange the equation, make moles the subject. So that's pressure times volume over RT. All I did is took this R and T to the other side, so it will be divided, and that gives you your number of moles. Put all of your data into the equation. So 2 times the volume, which is 1.1 into 10 to the power minus 3. Divide this by 8.31 times 333. And that will give you your number of moles. That gives me 0.0009937 mole. Okay, I have the number of moles. Now I need to find the molecular mass. So number of moles is equals to M over MR. You rearrange the equation for MR. So that's going to be MR is equals to M upon N. The mass is 1.60 grams. The number of moles is 0.09937. Try not to round off the value for number of moles prematurely. So unless you're giving it as your final answer, then you can round it off. But if you're gonna use it, so if it's a multi-step calculation and you first find the moles and then use it later, try not to round off the number of moles prematurely. Okay, so 1.60 divided by 37, and that gives me 16.10. And that's my grams. This was in grams, right? This was mass and this was moles. So the unit for MR is grams per mole. All right. Moving on to the next question. How many moles are there in 0.0600 meter cube of hydrogen gas at 283 kelvins and 50,000 pascals? Okay, the cool thing about this question is the volume is in the correct unit, 283 Kelvin. The temperature is in the correct units, and the pressure is also in the correct units. So we're ready to use the ideal gas equation here, and we're finding number of moles. So I can use this one here. So RT, so the pressure here is 50,000 times the volume, which is 0.0600. Divide this whole thing by 8.31 times 283 Kelvin, and put that in your calculator real quick. 0.6. That's 1.275 and so on. So now this is my final answer, so I can round it off. So I'm going to round it off to 1.278 moles. Okay. Next equation involving moles or number of moles is this, our good old friend. N is equals to M over MR. The M here stands for the mass of the substance. The MR stands for molecular mass. It's also sometimes referred to as molar mass. So if you're new to this, so I'm just going to write it out for you. Substance. Divide this by molar or molecular. Okay. So now in this question, we're going to be using this equation. So we've already used it here, by the way. Okay, how many moles of aluminum oxide are present in 5.10 gram of Al2O3? All right. The first thing is going to be find the MR. We do have the mass already, and we need to find the moles, okay? So use your periodic table and find the MR of Al2O3. So that's 27.0 times 2 plus 3 times 16, and that's going to give me 102. Okay, 102. Now I need to find the number of moles. So 5.10, divide this by 102, and that's going to give me 0.0. That's going to give me 0.050 moles. Okay. Then we move on to the next equation involving number of moles, which is, it's usually written as number of particles. I've already rearranged it for you guys. So number of particles is equal to number of moles times Avogadro's constant. I've rearranged it for number of moles. So, okay, so one important thing to note here is that we say number of particles, okay? We're not saying number of molecules, number of ions or atoms. We're saying particles, which means it includes atoms, ions, molecules. Okay, so when a question says how many molecules, don't get confused because you still have to use the same formula. And if another question says how many atoms, it's still the same formula. Okay, same for atoms, ions, molecules. All right, so how many atoms are in 0.450 moles of pure iron? So atoms. So we're going to use this one. Is equals to the moles, which is this, times the Avogadro's constant, which I'm sure you know by now. So it's 6.02 into 10 to the power 23. Put that in the calculator. That is 2.709. 2.709. So I can round it off to this, 10 to the power 23 atoms. If the question said molecules, you'd write molecules here. Okay. If it said ions, you'd write ions here. Okay. Moving on to the next question. How many moles are in 1.14 into 10 to the power, this should be the power 24 molecules if ammonia gas is present? Don't get confused by this. Don't get confused. We're still using the same formula. So you rearrange this one or use this one. So N is equals to particles, number of particles, divided by this. So you're gonna get 1.14 into 10 to the power 24 divided by 6.02 into 10 to the power 23 gives you 1.893. So that is 1.8989 into 10 to the power, no, that's it, 1.89 moles. Remember to always put the units, you see, because you might lose out on some marks. If it's a 2-mark question, you're supposed to calculate the moles using, for example, M over MR formula. Then maybe the 2nd mark is for the unit, so try not to miss the units. Okay, the next equation involving moles is the one where concentration and volume comes in. So number of moles here is equal to concentration times volume. So now you can use this if you've been given the volume in cm cube or even the volume in dm cube. But if you're calculating concentration, if you're finding concentration, right, then your volume should be in decimeter cube, because the standard unit of concentration is mole per dm cube, or if you like, It's the same thing. Okay, a solution of FeCl contains 0.2 moles of iron, so we have moles, iron 3 chloride and 0.4 dm cube. That's volume. What is the concentration? So we have the moles. We need to rearrange the equation. This is what the equation is. We have the moles. We want the concentration. So this goes here, and that gives you this. 0.2 divided by 0.4, and that's going to give you 1/2. And that's mole per dm cube. But let's say if this was in cm cube, then how would you solve the question? Then you would do concentration times volume, right? So your equation then, if this was in centimeter cubes, would become this, okay? And so what you have to do is divide the volume by 1,000. So if I solve the same equation, the same question, but supposing that the volume is in cm cube, then it's going to be number of, first we're going to convert the volume. So 0.4 divided by 1,000. So that's going to give me whatever answer in dm cube. And then I can use this volume in this equation to calculate the concentration. All right. Moving on to the last question. What mass of sodium hydroxide needs to be dissolved in water to give 50 cm cube of solution with a concentration of 2 mole per dm cube? Now, you might think, well, this question is a bit tricky, but look at what's been given in the question. So you've been given volume, okay? You've also been given concentration. Okay, so volume and concentration of sodium hydroxide solution. So I can use this to find the number of moles of sodium hydroxide solution. The concentration, now I told you if the volume is in cm cube, you need to divide that by 1,000. So concentration is 2.0. We're using this equation, this, n is equals to Cv. So concentration times the volume, which is this, divided by 1,000. That's gonna give you and that is 0.100 moles. What are we looking for? We're looking for the mass. Okay, can I use this equation next? Yes, of course, because I want to find the mass. I can calculate the MR. I have the number of moles, so it fits perfectly. Let's find the MR. So MR of what? Of sodium hydroxide. So that's going to be 23. Use your periodic table for this. 23.0 plus 16 for oxygen plus 1. And that is 40. Okay. Now I can use this equation. I can rearrange this equation. So N times MR is what gives me mass. So now I'm just gonna use my number of moles and the MR. So 0.100 times 40, and that's gonna give me 4. That's going to give me 4 grams. 4 grams of sodium hydroxide. And that's it.